All right, here we go for the last video of the section. So here we're going to look at a diagram. Here in this case, it's of a baseball field. But what I want you to notice is that, okay, this actually looks like a sliver or a section of a circle. We've got a 90-degree angle right here, so this would be the center of our circle. And we've got two equal distances coming out, and then we've got this length of the outfield fence. So this is actually called a sector right here. It says a softball field forms a sector with the dimensions shown. So a sector is just like a little piece of a circle. So you've got each length coming out from the center is your radius of the circle. And then this length right here is a partial length of the diameter around the circle. So we actually have a couple formulas that are going to help you solve this. So the two things we want to know the length of the outfield fence, so this distance all the way of this curved part, and then the area. So we want to know the area inside of all of these lines right here. Now notice this is a right angle here, but up to this point we've been working with triangles that have straight lines here. This is a curved side. So sine, cosine, and tangent aren't going to give us what we want here. Fortunately, we know a couple of other things. We have these two things called arc length and area of a sector. So look at, if we have a circle right here, a sector is just a portion of the circle that's cut out. So almost like taking a piece of a pie. Okay, so we know right here, if we take a sector that has an angle in here, we'll call it theta. That's called our central angle. And then each side coming out here is equivalent to our radius. So those two are going to be equal, because remember, the distance from the center of a circle to any point outside is just equal to the radius. And our arc length is this distance around here. So we have a couple formulas. The arc length, we're going to call that S. That's just equal to our radius times our angle. Now, the key here is our angle needs to be measured in radians. Okay? So in order for this arc length to work, for this formula, we have to have our degrees measured in radians. Okay, so an arc length is just the central angle times the radius. And the area is just 1/2 times the radius squared times your central angle. Okay, so again, key here is your angle must be measured in radians. Okay, so you can always come back to this picture. This is in your journal when it comes to arc length and sectors. So let's go back to our problem right here. So we want to find the length of the outfield fence and the area of the field. Well, let's go ahead. I'm going to write down our two equations here. We know that our arc length is equal to the radius times theta, and our area is equal to 1/2 r squared theta. The nice thing is that we just have these two equations that are going to tell us the length of the outfield fence and the area. The outfield fence is our sector, and the area is going to be this formula right here. So let's look first of all at this sector right here. So here we've got our distance from the center out. R is going to be equal to 200. And our angle right here is going to be theta. So in this case, we've got theta is equal to 90 degrees. Now remember, we need to have this equal to our degrees in radians. So if we take 90 and we multiply that by pi over 180, just like you learned in the last video, to translate into radians, we get that our length is equal to pi over 2. Okay, so that's our theta right here. So theta is pi over 2. So the first step is to convert your angle into radians. Now, for our sector, we simply take our radius, which is 200, times our degree in radians, which is pi over 2. And when we go ahead and simplify this, this cancels out to 100. We end up with 100 pi, which is just 3.14 times 100. So it's roughly 314 feet. Roughly 314 feet. That would be our length of our sector right here. So that's all you do. For a problem like this, you have to figure out what your R value is, your radius, and your theta, your central angle. And you have to convert it to radians. Okay, so next, let's figure out the area. Well, we already know that R is 200, so we're going to get 1/2 times 200 squared times pi over 2. Times pi over 2, because that's theta right here. So when we go ahead and simplify this, 200 times 200, we're just going to end up with 40,000 over 40,000 pi over 4. So that's going to equal 40,000 pi over 4. And when those simplify down, we're going to end up, I'm sorry, that's 4,000 pi. So we're going to end up with 1,000 times pi for our area right there. Okay? So we can go ahead and let's just check the answers right here. And we see that we get 10,000 pi, so 40,000 divided by 4 times pi, and 314 for our arc length. So very simple right here to go ahead and plug these in. Again, you can go back and you can follow along to see how we did these two. What I want you to do now is there's a slight modification of this. What I want to see, I want you to take this diagram, same diagram we used, and suppose the dimensions were 180 feet instead of 200. I want you to find the same thing, the length of the outfield fence and the area of the field. So the length of the outfield fence and the area of the field. So that's going to be your sector length and your area. Go ahead and type both of those into the text box right now. All right, and the last thing I'm going to have you do, I've got a link that you're going to go visit. So I want you to answer a few questions. I want to make sure you just answer those questions from the videos that you've watched in this assignment. So the last one from 9.1 and the 3 videos from 9.2. So I want you to think about what you learned from these videos, what you knew, what you thought you knew that maybe you didn't, or what you already knew, what you're still interested in. Go ahead and answer all the questions. I'm going to type in a URL. So in the question box that pops up, you're going to see a URL. When you go to visit that, it's going to request you to log in. You're going to have to use your student's, your srv.usd.net account to log in, so your Google School account. So make sure you log in. Once you do that, go ahead and type in completed in here. Now, if you type in completed, but you don't actually answer anything on the form, you're not going to get credit for doing the work. Okay, only type in completed once you've gone to the Google form, answered all the questions, and submitted it. Okay, if you have any questions, you can email me, or if the link's giving you problems, but make sure look at the link in the text box that pops up.